Hey students, in this video we're going to go through section 8.8, which is about solving inequalities. And our learning target today is I can write and solve inequalities. So first we're going to talk about a few properties of inequality. Our first one, addition property of inequality, says that when you add the same number to each side of an inequality, the inequality remains true. So just like we learned how you can add the same number to both sides of an equation and it remains true, the same is true about inequalities. So 3 is less than 5. If we add 2 to both sides, we get 5 is less than 7, still true. Over here, you can see how this helps us solve an inequality because if we have something that involves a variable like this, x minus 4 is greater than 5, we could add 4 to both sides, plus 4 minus 4 undo each other, leaving only x. X is greater than 9. And we know because of this property, this would be true. We also have the subtraction property of inequality, which says when you subtract the same number from each side of an inequality, the inequality remains true. So same idea, but with subtraction. 3 is less than 5. If you subtract 2 from both sides, we get 1 is less than 3. Still true. And we can see how if we had an inequality that involved a variable, so an algebraic inequality like this, x plus 4 is greater than 5, we could use that to help us solve it. We could subtract 4 from both sides, plus 4 minus 4 undo each other, leaving only x left over. X is greater than 1. That would tell us, well, we know based on this property, this is still true. X is greater than 1. These properties are also true for the less than or equal to and greater than or equal to symbols. And the reason we're learning these is because they're going to help us solve inequalities, which is going to be incredibly similar, almost the same as solving equations. So let's just jump right in. Example 1 says solve x minus 3 is greater than 1. Graph the solution. So when we learned to solve equations, we drew a line through our equal sign. Because this is an inequality, we're going to draw a line through our inequality symbol because that is the spot that separates the two different sides of our inequality, the two different expressions. Now, our goal is to figure out what x needs to be greater than. I don't want to know that x minus 3 is greater than 1. I just want to know what x needs to be greater than. My goal in all of these is going to be to get our variable by itself. That's our goal every time. So I don't want minus 3 there. How do I undo minus 3? Well, if I add 3, subtracting and adding 3 undo each other, leaving only x left over. But remember, when we solved equations, we said whatever you do to one side, you must do to the other. And we just learned that that's the same for inequalities. If I add to one side, I need to add to the other. So I'm going to add 3 to the 1. 1 plus 3, and I get 4. Now, the only difference that we've seen so far is that we have a different symbol in the middle, not an equal sign. So that means in my solution, I want to use that symbol, not an equal sign. I just want to carry that symbol down between my variable and my value. X is greater than 4. That is our solution. This just means that for this inequality, as long as x is greater than 4, our inequality is going to be true. So it could be a bunch of different values, anything that is greater than 4. So let's go ahead and graph that solution. X is greater than 4. So I'm going to start my number line at 0, 1, 2, 3, 4, 5, 6. So first I want to decide if I should use an open circle or a closed circle. I want to decide, is 4 a solution? Is 4 greater than 4? It's not. 4 is equal to 4, not greater than it. So 4 is not a solution. We'd like to use an open circle. We also could have known that based on the fact that we know greater than and less than, any symbol without a line underneath, we use an open circle for. Now we need to decide which way our solutions are, in which direction, to the left or to the right, are all of our other solutions. Well, x is supposed to be greater than 4, so we know it can't be 4, but it can be anything greater than 4. The numbers greater than 4 are to the right of 4. So we're going to shade and draw an arrow to the right to show that all of our solutions are going to be this direction, anything that is greater than 4. And since our variable is written first, we could have also just turned our inequality symbol into an arrow, and it would have shown us to shade to the right. Okay, part B, solve 15 is greater than or equal to 6 plus h. So again, we're going to draw a line through our inequality symbol. And as always, my goal is to get the variable by itself. So I don't want it to say 6 plus h over here. I'd rather have it just say h. So how do I undo plus 6? If 6 is added to something, how do I undo that? I would need to subtract 6. Adding and subtracting 6 undo each other, leaving only h left over. But remember, we learned that when you subtract from one side of an inequality, you must do the same to the other side so that it remains true. So I'm going to subtract 6 from 15. 15 minus 6, I get 9. And then don't forget, this is not an equation. We're not going to use an equal sign in our solution. We're going to carry down our symbol from above, greater than or equal to. 9 is greater than or equal to h. Now, instead of leaving our solution like this, we actually are going to go ahead and flip that around because not only will it make it easier to graph, but it's a little bit easier to understand or to think about when our variable is written first. So I want h to be first instead. Just be sure that when you're flipping this, you also flip the symbol. If the alligator was eating 9 here, it should still be eating 9 when I flip it around. So our solution is h is less than or equal to 9. This means that as long as h is anything that is equal to 9 or less than it, our inequality is going to be true. So there's a bunch of solutions, anything that's 9 or less. Now we're going to graph that inequality. I'm going to start at 5. I'm just randomly choosing to start my graph somewhere where I'll be able to have this number, 9, somewhere on my graph. So I randomly chose to start at 5. You could do anything you like as long as 9 is on your number line. So first, I want to know, is 9 a solution? Is 9 less than or equal to 9? Yes, it is. 9 is equal to 9, so it is less than or equal to 9. So I'm going to use a closed circle on the number 9. And again, we learned that when you have a less than or equal to sign, any symbol with a line underneath, we do use a closed circle. Now we need to decide which way to shade, which way to draw my arrow. So I need all of the numbers that are less than 9 because h needs to be less than or equal to 9. The numbers that are less than 9 are to the left. So I'm going to shade and draw my arrow to the left. This will show all of my possible solutions, anything that is 9 or less. And again, since we did flip our inequality around so that the variable is first, we could turn this symbol into an arrow and it would point in the same direction as our graph. Okay, we're now going to jump into the next piece. The multiplication property of inequality. When you multiply each side of an inequality by the same positive number, the inequality remains true. So 8 is greater than 6, that's true. Multiply both sides by 2, we get 16 is greater than 12, still true. And the reason it's important to know this is because it can help us when we have an algebraic inequality, like this one, x over 4, x divided by 4 is less than 2. If I multiply each side by 4, I know that ultimately this inequality below will be true. And I can get the solution x is less than 8. So it can help me solve my inequality because I know I can multiply both sides and still get something that's true. I also have the division property of inequality. When you divide each side of an inequality by the same positive number, the inequality remains true. 8 is greater than 6. If I divide both sides by 2, I get 4 is greater than 3. Still true. And I can use that when I have an algebraic inequality. 4x, 4 times x is less than 8. If I divide both sides by 4, I know that this inequality here, my solution, is true. X is less than 2. And just like our other properties, these are also true for the less than or equal to and greater than or equal to symbols. So these are very similar to what we learned about solving equations, properties of equality, but these are about inequality. So now we're going to solve some more inequalities. First, x over 5 is less than 2. Remember, x over 5, that just means division. I'm actually going to draw an arrow and write division. A fraction bar represents division. So x divided by 5 is less than 2. Just like the last couple, I'm going to draw a line through my inequality symbol. I want to know what x is less than. I want x to be all by itself. I don't want this divided by 5 piece here. So to undo divided by 5, I'm going to do the opposite. I'm going to multiply it by 5. Times 5 divided by 5 undo each other, leaving only x behind. But based on our multiplication property of equality, if I multiply one side of an inequality by a number, I need to do the same to the other. So 2 times 5, I get 10. And then don't forget the symbol in between. We're just going to copy down the same one from above. X is less than 10. This means that as long as x is less than 10, our original inequality will be true. So I'm going to go ahead and graph that. I'm going to start my number line at 8. Okay, so x needs to be less than 10. So first we're deciding if 10 is a solution or not. Is 10 less than 10? It's not, so we're going to be using an open circle. And again, we learned when there is no line underneath our symbol, we do use an open circle. But I want to shade and draw an arrow in the direction of all the values that would work. Anything that's less than 10, everything less than 10 is to the left. So I'm going to draw my arrow. I'm going to shade to the left. This shows all values that are not 10. 10 doesn't work, but anything less than that. And since our variable is written first, we also could have just turned our inequality symbol into an arrow. It would go in the same direction as our graph. Part B, solve 4n is greater than or equal to 32. We're going to draw a line through our inequality symbol. Remember, 4n means they're being multiplied together. So I'm going to write multiply there so I don't forget. So I have 4 times n, but I'd like n all by itself. How do I undo times 4? I do the opposite. I divide by 4. Times 4 divided by 4 undo each other, leaving only n left over. But our division property of inequality says if you divide one side by a number, we need to do the same to the other if we want it to remain true. So we're going to divide 32 by 4 as well. 32 divided by 4 is 8. And then we're just going to copy down our same symbol from above. So n is greater than or equal to 8. That is our solution. This just means as long as n is 8 or more, anything that is equal to or greater than 8, our inequality will be true. I'm going to graph the solution. I'm going to start at 6, 7, 8, 9. Okay, so first we're going to decide if I should put an open or a closed circle on 8. So we're deciding is 8 a solution? If n was 8, is 8 greater than or equal to 8? Yeah, it is. It's equal, so it is greater than or equal to. We're going to use a closed circle on 8. We also could have seen that since there's a line underneath, we use a closed circle. Now I need to draw my arrow and shade in the direction of all the values that are also solutions, anything that's greater than 8, because we have 8 already. Now I need everything greater than 8. That's to the right. So I'm going to shade and draw my arrow to the right. And remember, since our variable is written first, we could turn our symbol into an arrow and it would point in the same direction as our graph. Now our final example, we're going to combine some of the things we've learned. This says solve 2x over 3 is less than or equal to 4. So I am going to still draw my line through my inequality symbol. Now we have two things happening here. X is being multiplied by 2 and it's also being divided by 3. So I need to undo these things one at a time. I'm first going to undo this divided by 3 part. If I get rid of divided by 3, I just have the 2x piece left. So times 3 divided by 3 undo each other, leaving only 2x left over. Notice that it's 2x, not x only, because I haven't even touched this 2. So I got rid of the 3, haven't touched the 2 yet. If I multiply one side by 3, I need to do the same to the other. 4 times 3 is 12. We'll copy our same symbol in between. So now we have 2x is less than or equal to 12. 2x, that means 2 times x. To undo multiplication, I'm going to divide by 2. Times 2 divided by 2 undo each other, leaving only x left over. But whatever I divide one side by, I need to do the same to the other. 12 divided by 2 is 6. And then we'll copy our same symbol in between. So we get x is less than or equal to 6. This just means as long as x is anything that is equal to or less than 6, our inequality will be true. Now we're going to go ahead and graph our solution. So I'm going to start my number line at 3. So first I want to decide if 6 itself is a solution. Could x be 6? Is 6 less than or equal to 6? Yes, it is. 6 is equal to 6, so it is less than or equal to. It's a solution. We use a closed circle. And again, line underneath, we know closed circle. Next, I need to shade and draw my arrow in the direction of all the other solutions. So anything that is less than 6, that's going to be to the left. So I'm going to shade and draw my arrow to the left. And because our variable was written first, we also could have turned our symbol into an arrow and seen the same thing, that our arrow would point to the left. So the bottom line here is that solving inequalities is almost the same as solving equations. We use the same steps, our line through our symbol. We do the same step to both sides. We just have to make sure to use our inequality symbol in our solution and not an equal sign.